studied numerous chemical reactions, making careful observations and measurements along the way. He was able to determine the mass ratios of the elements involved in those reactions. The results of his research are known as Dalton's atomic theory, which he proposed in 1803. The main points of his theory are summarized in Table 2. Dalton published his ideas in a book, an extract of which is shown in Figure 2. Get it? Compare and contrast Democritus's and Dalton's ideas.
Okay, so
Figure 2. In his book, A New System of Chemical Philosophy, John Dalton presented his symbols for the elements known at that time and their possible combinations.
Okay, so if we had Democritus and we said he was the matter made up of atoms, right? Aristotle went completely against that, said it couldn't be because there was no empty space. John Dalton came up with the atomic theory. What was his about?
Revising Democritus' theories that atoms are what makes everything.
Right, so he actually came up with he liked the atoms, right?
So he revised the theory of it, and he could actually do tests to somewhat prove it.
Correct. He had tests to prove because there was more technology there, right? He also came up with letters, symbols, right? For the atoms, the elements that we had so far. As it says there, that he actually gave an identity to size, mass, and chemical property. Everybody good so far? Okay, let's go to the next page. And this will be it. It's very short and sweet, and then we'll talk.
What would life be like if people still thought atoms didn't exist? Would it be changed then?
I think so. Because, we would still be trying to find out what makes up everything, right? But today we've got technology, but they keep expanding.
Conservation of mass. Recall that the law of conservation of mass states that mass is conserved in any process, such as a chemical reaction. Dalton's atomic theory easily explains that the conservation of mass in chemical reactions is the result of the separation, combination, or rearrangement of atoms. Atoms that are not created, destroyed, or divided in the process. The formation of a compound from the combining of elements and the conservation of mass during the process are shown in Figure 3. The number of atoms of each type is the same before and after the reaction. Dalton's convincing experimental evidence and clear explanation of the composition of compounds and conservation of mass led to the general acceptance of his atomic theory. Dalton's atomic theory was a huge step toward the current atomic model of matter. However, not all of Dalton's theory was accurate. As is often the case in science, Dalton's theory had to be revised as additional information was learned that could not be explained by the theory. As you will learn in this chapter, Dalton was wrong about atoms being indivisible. Atoms are divisible into several subatomic particles. Dalton was also wrong about all atoms of a given element having identical properties. Atoms of the same element can have slightly different masses. Figure 3. When atoms of two or more elements combine to form a compound, the number of atoms of each element is conserved. Thus, the mass is conserved as well.
Okay, take your textbooks and put them on the wall, please. I need you to get your periodic table that I gave you last week.
There you go.
the paper that you have in front of you and read it, please? Okay, so I'll go along with you. So at the top it says step 1, complete the square for each of the elements by adding the atomic number, name, and the atomic mass. Write the atomic number on the top of the square, write the element's name and symbol, write the atomic mass on the square. That's what we're going to do today. But before we do that, we have to go over some information. Now, do you have your periodic table out? That's this really hard one that I gave you. So let's talk about the periodic table. And what I need you to do is draw in your ISM book a line. A line in your ISM book where you took the notes from the textbook. And now what you're going to do is you're going to take notes from me. Is everybody good? Okay. So we have learned so far that we have on the first column, what group is that? What is group number 1? Alkaline metals. Okay. How about group number 2? How about group number 3 through 12?
Transitional metals.
Okay. How about group number 13? Boron family. Remember?
Oh, that's the thing we left.
14, carbon family. 15, nitrogen family. 16, oxygen family. Yep. Halogens. And 18 is noble gases, right? Okay. So we understood that, and those are groups or families, right? So groups go down this way, right? What goes across? Periods. What do you remember about the 7 periods that we have on the periodic table? What do those periods stand for, since we know that the groups represent what type of metal they are? Periods tell us how many energy levels there are. You don't have a clue what those are yet, and if you do, that's great, but we're not going to talk about energy levels today. What we're going to talk about is the atomic tile, okay? So, draw your atomic tile. Has everybody got their head up, ready to go? There we go, okay? Now, on our atomic tile, we have, and I'm going to use hydrogen as an example, so I'm just writing it down straight from my table. Okay, so I just drew it just like it is on my table, periodic table. So hydrogen is the name. Okay, 1 is the atomic number. H is the symbol. 1.01 is the AMU, which is the atomic mass unit. And then 202 is the EN, or the electromagnetic number. Everybody good so far? handout we've got in front of us. What I would like you to do is I would like you to skip the first page and go to the second page. So, here's the first page. I said skip it. Put it on behind you. And we're going to go to the second page. Is everybody on the second page? Okay. The very first one you see is boron, correct? Which is B. So on your paper, what are you going to put? In the tile itself, you've got this. You've got a line, you got a B, you got a line, and you got a line. Is everybody with me? Okay? So what am I going to put on the very first one? 5. What am I going to do on the next line? Boron. And then what am I going to put on the third line? What is the AMU on your periodic table? Does everybody understand? Boron's number 5, and I got 10.81. Everybody good so far? Okay? Take this paper, take your pencil, stand up, and let's go to the labyrinth. Now, if you were falling asleep, this would be a good time to stand. If you think you'll be okay sitting, that's fine with me. In front of you, you have a huge periodic table, correct? Everybody got one? So what I want you to do is your goal is to go through, and I want you to do the 2 pages of your handout that I gave you. You can do every single one. Does everybody understand what we're doing? All right? Y'all can talk to each other if you want to. You can check with each other to make sure that you've got it right. I need you to work on that. And when you get done, come back and sit back down.